Okay, this is from exercise level 2, question 7. So we've got these equations and we're asked to find the unique solution in two ways, by writing the equations as a matrix equation and secondly by eliminating x and z and then substituting. Okay, so let's start with the matrix equation. So we need to be careful because we need to remember that when we write the coefficients it needs to be x, y, z. And this doesn't have all of those, so we would have 1, there's 0y, so that's going to be there, and then 1z. This second one we've got 0x, 2y, and 3z. In this last one we've got 1x, 7y, and 0z. So that will be x, y, z equals 1, 1, 1. Now the question tells us that there is a unique solution, so we already know the determinant is 0, but in order to work out the inverse, we would need to find it. I mean, in this case, in fact, we can just use a calculator because there's no unknowns, and so we might as well just do that. So what we need to do is rearrange, well, not rearrange, but we multiply both sides by the inverse of that. So it's inverse of that times by 1, 1, 1. Okay, and I'm going to get a calculator to do that. Right, so I'm going to go to matrix mode. I'm going to define matrix A as this 3 by 3 one. Okay, then I'm going to define matrix B as this one. Then I'm going to do matrix A inverse times matrix B, which will give us our answer. So if I multiply that out, I get 16 over 23, 1 over 23, and 7 over 23. So that would be the first solution. X equals 16 over 23, y equals 1 over 23, and z equals 7 over 23. So that's the first method. Second method, yes, we know what we're doing. Okay, so let's label these equations 1, 2, and 3. And so we have to eliminate x first. So let's do that by subtracting equation number 1 from equation number 1 minus number 3. That will give us x minus x, which is nothing, z minus 7y equals 0, and then we have already equation number 2, 2y plus 3z doesn't include x, so we've already eliminated x, so it says then eliminate z, so let's label this one 4, and remember that this is just copied number 2. So to do this we want to eliminate those z's, so let's do 2 subtract 3 times 4. Okay, so we're going to have 2y plus 21y, so that's going to be 23y. Then we're going to have 3z minus 3z, perfect, and then 1 minus 0, so 23y equals 1, y equals 1 over 23, which is what we got there, so that's good, that matches. and then we need to substitute back in to find our other values. So to find x, let's substitute back into number 3. X plus 7 over 23 equals 1. So x equals 1 minus 7 over 23, which is 16 over 23, which is what we had over there. Perfect. To find out z, let's substitute that one into 1. 16 over 23 plus z equals 1. So that works. 1 minus 16 over 23 is 7 over 23, which is what we have. Just to be absolutely sure, let's substitute back into number 2 just to make sure that it all works. Those things that we worked out, that's 2 over 23 plus 3z, so 7 times 3, 21 over 23 equals 1. And yes, we can see that it does. So this definitely works. The solutions are the same using both methods.